This is the KK Moon DIY calculator kit. I got this from Amazon. It comes with the acrylic case um, and a sheet of instructions. Of course, I'm sure there was more online, but this actually was enough to get this together. Uh, it actually assembles fairly quick. There's not that much, not so many parts. It looks intimidating because it's big pieces, a lot of big pieces, but when you start putting it together, it gets rather simple fast. Happily so. Now, one tip I do have when you're, it'll come with a sheet of a couple of these printouts of the keys, because these are basically paper pieces that are in these key tops, and these key tops snap over the paper. When you're trimming the, you can see it on this one here, I left a little bit of an edge around that. Before I figured out the trick, there's a black outline around the button on the printed page. You need to trim inside the black line, just a hair, and things will drop in here just right, and you won't have this problem where it's misaligned, folded over the other edge. Which initially I thought that was a good idea, but later on, in fact, that's like this one here, that became a bit of a challenge. But yeah. But all in all, pretty easy assembly. The one thing I did change, and there's a previous video about solvent welding acrylic, and that's what I did to the sides here. So rather than holding them together, there would have been a screw back here, and rather than, another change I'm making is, rather than putting the two coin cells in there, I'm just going to hook this to an external battery pack or power supply, as opposed to using the two button cells. And it's just a personal preference. But to eliminate the screws holding the bottom together, I went ahead and solvent welded all of the joints. Now, I did not solvent weld the black plastic or black acrylic to the bottom. I left that so I can remove it if I have to service it. But as far as that's concerned, I solvent welded the case. Now, one thing I didn't catch was that circuit board sits on these spacers, which are acrylic also. So what I ended up doing was I dropped a screw through it. Find the flat side. There you go. You want to put the flat side toward the case. I'll eventually get that right. But anyway, you get the idea. I put the spacer on the screw. I dropped the screw through the hole in the this plastic for the 5 points for the circuit board, and then I just did the solvent weld to it because it appears to be acrylic as well, and that worked like a charm. Now, the black plastic does show a lot of fingerprints. But yeah, all in all, it's a very quick unit to put together. I did have to use a pair of pliers to bend this connector back here. So you can see that. Just to bend it a little bit because of this angle. Otherwise, this tends to want to be up flat. So I was able to bend it along the black plastic here to get a better angle, so it's not under so much tension. It's still under some tension for me just getting these screws to line up to put the nuts on. Yeah. Looks like I missed a couple pieces of paper, but that's all right. Let's see, let's get a power source out here. for this, we'll just use my box here. Alright, we can do basic math with it. 1 plus 1 equals 2. Right, let's clear that. Let's go to that. Where it says color ring. Let's press 4. 7. Black. See, I'm actually, there's brown. So there we go. Which that is a 1% tolerant resistor. Alright, and that's of course for a 5 ring. Now if I wanted to do a 4 ring, let's see. There we go. We can change that number there. Well, here's a quick timeout feature. Might be upset because I'm doing it from. Then we can of course change it for 4, where we do green. So let's do green, red, yellow, and press gold. And that tells us it's our 520K at 5% tolerance. First we hit this to reset, then hit mode to go to other functions. Okay, so let's do this one here. So let's say we want to drop 4 volts. And then we want to drop 20 milliamps. We're hitting that button to get to the next one. And then we're going to want to know what size resistor we need. And then we need a 20, for that we need a 200 ohm resistor. Let's see what else we can do here. Alright, so we can go here, and this allows us to convert decimal to hexadecimal. Alright, and back and forth. Alright, so alright, I see how this works. So get here, and we can use this to select what base it is. Like this is base 10, so if I enter 8 and hit equals, oh, that would be correct, yes. But if I entered a 10, 81, so let's do a 10, then we get an A. There we go, that's right. 8 was correct as well. Now, so we want to do this, and there are, so we want to do a hexadecimal 12, which would be 18 in decimal. So it can convert decimal to hex. It has a very quick timeout, and I assume that's to conserve the battery. Let's see what else we got. That's it. Then we're in basic math again. So not too hard to operate. Instructions, just one page of instructions, so not bad, and it's not that difficult at all. I was pretty close earlier. So there you go. That's the review of the DIY, actually, calculator. with acrylic case and buttons. Again, easy assembly, very low frustration for me. Trim the button labels close on the inside of the black line, and you'll get them, they'll drop right into these button caps perfectly. And how they're printed out is how it's to be laid out on the keypad. There's apparently been some revisions since these instructions were made. But all in all, again, easy to assemble, no real challenge. Yeah, just overall a nice, easy little kit to put together to relax with. Alright, that's the end of the review. Please comment, rate, and subscribe.